Every project starts with numbers, precise measurements, accurate calculations, and a standard process. But how do you turn raw calculations or raw measurements into a reliable cost estimate? This is what I am going to show you in this video, and let's start. So the process that we are about to discuss here is very simple. The first thing, I need a measurement sheet where I'll be doing or taking all my quantities, and I will be calculating the volumes of these concrete elements. And after that, I'll need some other sheets to calculate the steel reinforcement for the different elements again. And all of this information will go to my BOQ as an estimate so that I can start estimating the cost and analyzing the price. And now let's start with the first point, which is the quantity sheet. This is also known as measurements sheet or quantity sheet because this is where you will be taking your measurements. And actually this sheet looks like this. I'll have first thing the item here. So I'll be talking about the different BOQ or project items. And then under each of these items, I have some other sub-items. And for each sub-item, as you can see, I'll be calculating the numbers and either the length and the breadth and the depth or height, or area and one and again depth or height, and we will get into that. Just the quantity column here is multiplying these four columns, the number by the dimensions by the depth or height. So here, for example, let's start with the first item, which is the foundations. So under the foundations, I have some isolated footings and I have rafts as well. So the isolated footings, F01, here I have two numbers and I am measuring this number from the drawings. And these are the dimensions, L and B, or length and breadth. And I also have thickness or depth of this footing, which is 0.4 meter or 400 mm or 40 centimeters. So when I go and multiply these four numbers here, as you can see, I'm getting the quantity or the volume. This is the volume of this sub-item. Now when it comes to rafts, I have one of each type of raft, but here instead of measuring the length and width, I'm just measuring from the drawing. I am measuring the area and I am multiplying here by 1. So whenever I put 1 here and highlight it in yellow like that, that means that this is an area, not L and B. No, it is area and 1. And the same thing, I am multiplying by the depth or the thickness to get this quantity. So when I do this for all of these items, I'm getting here the total volume of the concrete for the foundations. Similarly, when we go to the next item, which is the strap beams, here you have a strap beam, and this is the cross section, 250 into 1000 mm. And again, the numbers, I have 1, and why I am putting 1 here, because the length that I have measured for this beam is the total length of all the strap beams that I have. So this is the total length, and this is the cross section here, 0.25 into 1. And again, the same formula here, which is taking the volume. So I'm multiplying the four numbers and I am getting the volume for the strap beams. The next item is the retaining walls and upstands. And I have these retaining walls here, as you can see, for the lift, for water body, for a storm water tank, underground water tank, pool, etc. So for these retaining walls, from the drawings, I am again measuring the length, which is this one. And this is again the total length of the walls in the drawings. That's why my number is just 1. If these walls are coming into pieces, so for example, you have 5 pieces and the length of each piece will come here. But because this is my total length, I am putting here the number as 1. And this is again the cross section. So this one is 0.25 into 1.3, and I am multiplying the four numbers here to get the volume. Then I am taking a summation here. So this is how I am taking the quantity of the retaining walls. And the next item we have here is the neck columns. So for the neck columns, actually under the sub-item, I am grouping the neck columns by height. So for each column or for each neck column, I am looking at the base level and the top level, from where this neck column is starting and up to where it is going. And these two levels will determine the height of the neck column. So for example, here the base level is minus 600 mm and top level is plus 350 mm. So neck columns that are having this height will be 95 centimeters or 0.9 meter. And which columns or which neck columns are having this particular height, 0.95 meter? These ones. So I have here C1 and two numbers, and this is the cross section of the column 0.25 into 0.6, and this is the height as we discussed, which is the difference between these two levels. So again, when I multiply the four numbers, I am getting the volume of this neck column, which is having two numbers. And similarly, I am doing this for all the neck columns in the project. So I have another group of neck columns that are starting from minus 700 instead of minus 600, which means that the height of these neck columns is 10 centimeters more than the previous ones. So again, when I go and multiply these numbers, I am getting the quantity of these neck columns. And when I take a summation here, I am getting a summation of all the neck columns that I have in my project. So this is the total volume or total concrete volume of the neck columns in my project. When I go to the tie beams, I have these types of tie beams. Here, tie beam 1, 2, 3, 2A, CTB1 and all. And we have the cross section again. And again, the number is 1. Why? Because I am measuring the total length from the drawing, and that's why I am putting the number as 1. And then I am just multiplying by the cross section, which is 0.25 into 0.5, and for this one 0.25 into 0.65. So it's just multiplying the four numbers, and again I am getting the total volume of the tie beams in my project. The next item we have here is the slab on grade. And when I start talking about such items like slabs or slab on grade, I am measuring the area from the drawing. So here for my project, the slab on grade is 100 mm thick. And because I am measuring the total area from the drawings, again I am putting the number as 1. So 1 into the total area of the slab on grade, and then here I am multiplying by 1 and multiplying after that by the thickness of the slab on grade to get the volume. And these are two thickenings. Sometimes in the slab on grade you don't have a ground beam to build a wall in this location, so just in some areas you increase the thickness of the slab on grade. So I am measuring these in length, and I am just multiplying by the cross section again to get the volume, and when you take a summation here, you get the volume of the slab on grade. The next item is cover slabs, and these are also like on the grade level or on the ground floor level, but they are cover slabs or suspended slabs for the tanks. So I'm treating them as suspended slabs and not slabs on grade because they are suspended or hanging on walls of the tank. And again, from the drawings, I'm just measuring the total area and multiplying by 1. And after that, multiplying by the thickness to get the volume of this. And when I take a summation, I'm getting the volume of the cover slabs. And like that, you can say that we have finished the substructure items, and now we will be going to the superstructure items. So I'm starting here with the beams. And actually, for this project, the beams are coming at different levels. So I am taking the first level, which is 2.6. And in this level, I am having these three beams. And of course, the beam name or code, and also the cross section. So here in this case 0.2 into 0.5, and again the number is 1 because I am measuring the total length from the drawings, and I am multiplying this length by the cross section to get the volume. And when I do that for all the beams in the project, and in this project there are many because different levels are there, I am just taking the summation down here and I am getting the total volume of the beams. So all this time I am just calculating the quantity of concrete or the volume of concrete required for these elements. And the next item will be the suspended slabs. So here I have suspended slabs of different thicknesses. And as you can see, again, I am measuring the total area from the drawings. So I am keeping the number as 1. And if you noticed, the number is becoming something other than 1 only in the case of columns. Because when I am measuring the quantities themselves, or when I'm taking the measurements from the drawings, I go for the totals. So here, this is the total area and multiplied by 1 for each slab thickness. And then I am multiplying by the thickness of the slab to get the volume. And a good question here can be, this slab is 200 mm thick, and this one is also 200 mm thick. So why I am keeping them as two separate items and I didn't measure them from the drawing as a total area one time? Because actually the steel reinforcement for these two slabs is different. So I need the area of this one and I need the area of this one, so that when I go to the next step, which is calculating the steel reinforcement, I can calculate the steel for both the slab, even if they are having the same thickness. And I also have some slab edges here, some decorative elements. So again, measured in linear meter multiplied by the cross-section area. And actually, these decorative elements are triangular shape. So for example, triangle area will be 0.5 into this. So that's why the number here is 0.5. It is not like a 0.5 element. No, I'm just putting the 0.5 here so that when this 0.5 is multiplied by the cross-section area, I get an area of a triangle, and then when it is multiplied by the length, I get the volume of this, and here I am getting the total volume as well. After that, we have the columns, and here in this project I have ground floor columns and first floor columns, and they are having the same height. So I'm just grouping the columns as ground floor and first floor, and for each column how many numbers are there and what is the cross-section area, and then multiply it by the height to get the quantity or the volume here, and here a summation to get the total volume of the columns. And the last item is just an upstand for a parapet 20 by 20. So again, I am just getting the volume here, similar to all the previous items. And quickly, if we are meeting for the first time, I am Ahmed Adel and you are watching Cost Engineering Professional. And here I help you develop the required skills and enhance your knowledge to elevate your cost engineering career. So if this is what you want, you can quickly subscribe. And now after I have finished everything in terms of concrete, I have the dimensions of everything, slabs and columns and beams and all of that. So using these dimensions, now I can start calculating the steel reinforcement. And I will start with the foundations here. So this is a template that I am using, and I'm using this template to calculate two things: the steel reinforcement and the shuttering or the formwork required for the item as well. So as we said here in the quantities, when we go up to the foundations, the first foundation was an isolated footing. And I have a template that calculates the steel reinforcement of the isolated footing. So all I have to do is to start linking and getting the dimensions for this template from my measurement sheet, because the dimensions are already here. So as you can see, this is the sub-item F1 1.5 into 1.5 into 0.4. It's coming here, and it's a formula that is getting this value from our quantities or measurements tab. And again, when I apply the same formula here, I am getting the numbers and L and B and D. So when these four numbers are multiplied, again, I am getting the volume, which is the same number that I got previously, but this is not what I want because I have the volume already. But I have another formula here, which is this one, which will go take these numbers and calculate the wall area or the side area of the foundation to give me the shuttering of the foundation. And then here we have the bottom reinforcement and the top reinforcement, and under the bottom reinforcement we have two directions, and for the top also two directions. So we are just inserting here how many bars or steel reinforcement per linear meter and what is the diameter of the steel rebar. And I'm doing this for all the four directions, two directions bottom and two directions top, to get the steel quantity here. And actually, as you can see, it's a big formula here, this formula, and if you ask me to do this formula again right now, I'll not be able to. I created this template like really long ago, but in the end, applying these formula, like using all these entries, somehow we are getting the steel quantity in kg. And the steel ratio is just dividing the steel quantity by the volume of concrete to see how many kilograms of steel are there in 1 cubic meter of this element. So here for this footing, I am getting 63 kilograms, which is a very light steel. And the formwork ratio is similar, but you divide the shuttering area by the volume to see how many square meters of shuttering are there in 1 cubic meter of concrete for this item. The next item for the steel reinforcement is the raft. And as you can see here, I had these 5 or 6 numbers of rafts, and for each of them, again, I am getting the dimensions from my measurement sheet, and I am putting the dimensions here. And similarly, I am getting the volume, which I already have before. But for the rafts, actually, the shuttering area, you should interfere here manually. It cannot be calculated using a formula. Why? Because the raft will have a irregular shape. And what information are we having regarding the raft? Here we have only the area and the depth. But if you want to calculate the sides of the raft, you actually need the parameter of the raft. So that's why here, as you can see, I'm just putting the parameter manually, and I am multiplying by the depth, or the depth can be taken from here, but the parameter should be measured again from the drawing because you measured only the area. Now you need the parameter in order to multiply it by the depth to get the sides of the raft. And this is how we are getting the formwork or the shuttering for the raft. And then the next part is the steel reinforcement. And actually there is an interesting part here, because usually in the rafts you will have extra reinforcement. So this schedule that you are seeing here, or this template, actually calculates only the main steel, because for this much of area of a raft we have these two, the bottom and the top reinforcement, and we have two directions under each one of them. So this will give me the main steel reinforcement. But what about the extra steel reinforcement, which will be like near from the columns and some locations and all of that? So for these ones we will have to count them. And as you can see here, this template here, we are calculating the main reinforcement, but here there is one column that says allow for extra. So in addition to the steel reinforcement that we are getting from here, we need to add something more. But from where we get this, this is for the extra steel reinforcement. So we go to the drawing and we start counting them. So for example, here I have a piece of 6 meters and it is distributed over 7.5 linear meters. And this is EB1. And for us, EB1 was 7 per linear meter and the diameter is 16. So again, I am collecting this information from the drawing. I am counting this. I have one of it, for example, this one I have 2. And what is the length of the steel reinforcement piece? And also we have the distribution length. And using the distribution length and how many numbers per linear meter, we can get the total number of these extra reinforcement. And from the diameter, we can get the weight, and applying a formula here like that, this one, we can get the weight of the extra steel reinforcement. So when I take a summation here, I am getting the total weight, and this total weight will come here to be added to the main reinforcement for this particular raft. So here, as you can see, the steel that I am getting, this 6,000, it's the main reinforcement plus the extra reinforcement. And the ratio here is 131 kilograms per cubic meter, including the extra steel reinforcement and the main steel reinforcement. And similarly, we are doing this for the beams. So we have in the project, we have strap beams and we have tie beams. And again, I'm just getting the dimensions from my measurement sheet and then putting the steel details here to get the weight of the steel using this complicated formula and all. So I have for the strap beams, for the tie beams, and for the drop beams in different levels. So as you can see, it's a time-consuming task actually, and it requires focus, but in the end, it gives you the total steel required for the beams and the steel required for each beam. And you get also here, WA is the area or the sides area of the beam, 2 sides and the bottom. And this BA is only the bottom area because it is used for calculating the scaffolding required for the beam. So it is different from the U section. And then we have also for the parapet, which I am treating here as a beam. And like that, I am getting the steel quantities for the beams in the project. And for the RC walls, same thing. I am just using the same formula to bring the dimensions from the measurement sheet. And here I am entering the steel details to get the steel quantity so that I can have the steel quantity of the retaining walls. And for the project columns as well, the neck columns and the core walls and the columns and all of that. And we are getting the steel quantities. And for the slabs also, we have for the slab on grade, for the slabs, for cover slabs for the tanks and for the suspended slabs. And again here, the same concept of the extra reinforcement is applied, because for this slab, for example, this is the main reinforcement, but I have extra reinforcement as well, which needs to be added here. So we go to the drawing and we count them. As you can see here, these are the numbers and the length of every piece and the distribution length and the numbers per linear meter and also the diameter to get the total weight here, which will be added to the weight of the steel or the main steel reinforcement to get the total weight of the steel required for the slab. And once we have all these information, we have now the concrete volumes and we have the steel reinforcement in kg and we have the shuttering or the formwork in square meter. We can take these items and go here to a BOQ. As you can see, I have the poured concrete. Actually, this one is for the PCC. We didn't talk about it because it's here, so I'll unhide. So again, I am going against each item where the PCC will be applicable. I am just putting a formula to calculate the PCC for this item, and then I am taking a summation down here to get all the PCC in my project and also the volume of the other concrete elements. So all of these things will come here to the BOQ. As you can see, this is the PCC and all the other items, the foundations, strap beams, neck columns, reinforced wall, tie beams, slab on grade, tank slabs, columns, beams, and so on. And the next part will be the steel reinforcement. So I'm just taking a summation of all the steel required for all the elements, and I am putting it here as one item in my BOQ. And for the form work, I am getting them item-wise. Why? Because the rate might be different from foundation to, let's say, neck column, to a slab, to a beam. So that's why we are keeping them separate. And now you have your BOQ, including the items and the unit of measurement and the quantity as well. And now the last part will be to estimate the cost. So in order to estimate the cost, you need the cost of the materials, equipment, manpower, and subcontractors required to execute this item. And this is my cost estimation template, and I have explained this template in more than one video. I'll keep links in the description so that you can watch these videos to learn in details or more details about how this cost estimation template works. But simply here what I am doing, I am going against each of these items that I have identified and quantified, and I am putting the rate of the materials and the equipment and the manpower and subcontractors required for this item to get the total cost rate here for this particular item. And then I am having a markup column here so that I can get my BOQ rate, which will be multiplied by the quantity to give me the BOQ amount. And the BOQ amount will be calculated for each item. And when you take the summation down here, as you can see, you can get the estimate or the price for the project as a whole or for the section that you are working with in your BOQ. It doesn't matter, but the concept or the system is like that. This is a structured system that you can use so that you can quantify and estimate, and all your information will be linked to each other. And when you use this system for estimation, you will get your total cost, and you will also get a brief breakdown of the cost for the materials, for the equipment, for the manpower and subcontractors required for the work. And after you have all these numbers and all these details, you can do some analysis for your project to review and check your estimate. So for example, what I am doing here, total concrete quantity is this much. And actually I have the total amount for or as a price and the total amount as a cost as well. So when I divide these amounts by the total volume of concrete in the project, I am getting the cost rate and the selling rate. And because you are in the market and all, you will be looking at these two rates and you will understand your estimate or the way you calculated the concrete and the steel. Is it right or wrong? By looking at this total cost rate and total selling rate or BOQ rate. And also from these estimates, we have the total for the shuttering works, because we have the manpower here separate. For the form work, we are putting the manpower here. So if we take a summation here, we can get the total of the shuttering works. And when you divide this total as a money divided by the volume, you are getting per cubic meter how much are the shuttering works in terms of labors or manpower. And again, these numbers sometimes they do make sense for you and they will guide you whether this estimate is right or wrong, or need fine-tuning, need the price to be higher or lowered. You can make such decisions based on this brief summary of your calculations. And again, for the steel fixing works, total divided by the total volume of the concrete works. So we are getting the steel fixing per cubic meter, and you are getting a rate here per cubic meter for the steel fixing. Even you estimated the cost in kilograms. You have calculated the quantity in kilograms and you put your cost in kilograms, and now you are checking how much is it per cubic meter. So you are looking at it from a different angle to see your calculations are right or wrong. And similarly, you can do all kinds of reviewing and validating the estimate and all of that. And now that you have seen how to prepare a measurement sheet and how to estimate the cost of a project, there is always more to learn. And I am letting YouTube decide what you should watch next, because most of the time they choose the right video for you and it will be here next to me. So go ahead, watch the recommended video, and I'll see you again in the next one.